Hello, geometry students. We're here in section 4.3, and we have some new vocabulary. We have congruent. We have congruent polygons, corresponding parts. Definition of congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. So we have a polygon. Actually, they're a triangle, but still considered a polygon. And we have that angle A is congruent to angle H. Okay, so basically you can see that based on the picture here, the way they indicated here with the two little lines. You also have it here, so that's how we can decipher. And then angle K, it looks like, is with angle C. And angle J is with angle B, as you can see in the statement. Okay, we also have corresponding sides. Corresponding segment AB is congruent to HJ. So you're best to kind of, if someone says, hey, which one's corresponding with AB? Okay, so you want to go from the thing that has 2 up to the one that has 1, and you want to name it in that order. So AB, so go to the 2, which is the one here, H, and then go to the one that only has the circle, the arc here, which is J, so it's HJ. So sometimes it's a little hard if the triangles are kind of oriented in a kind of a strange way. So then our congruent statement is simply saying that we have a triangle ABC is congruent to HJK. Okay, identifying corresponding congruent parts. Show that the polygons are congruent by identifying all of the congruent corresponding parts, then write a congruent statement. Okay, so we have angle A is congruent to angle R. We're not told that they are, but we're assuming they are. Okay, so if they're corresponding, and we know that these two are congruent. And then we have all the sides AB goes along with RT. So if they're in the exact same orientation, then it's a lot easier. You can see AB and RT. Sometimes if the second figure here is kind of like rotated, sometimes it's hard to tell. So my angles, A is congruent to R, B is congruent to T, C with P, D with S, and E with Q. And then the sides, AB congruent with RT, BC congruent with TP, side CD is congruent to PS, line segment DE is congruent to SQ, and then finally line segment EA is congruent to QR. All corresponding parts of the two polygons are congruent, therefore, and then they just name the polygon. Instead of saying like triangle ABC, they just have ABCDE is congruent to the polygon RTPSQ. Okay, so check your progress. To support the beams on the fence, form congruent triangles. So they're telling us that they're congruent. Which of the following congruent statements directly matches corresponding angles or sides? Go ahead and stop your video. All right, let's check this out. We have segment AC. Okay, so we have our segment AC, which is the segment here, is congruent with the DF, which is simply down there. Okay, angle ABC, right, being this angle right here. Okay, and they're saying EFD, so it's kind of hard to tell that those actually are not congruent. So I would say that this is a poor example. Okay. All right, use corresponding sides. Okay, in the problem, it says in the diagram, we know that triangle ITP. So, goes from here, 65, to T, which is 75, to P, which is 40. So, we can match up the little I to N. See that? So, we know that my N, just so we can match this up, we could say that that's 65. Okay, and then the T matches up with the G. Right, the T matches up with the G. And so the t is 75, so the g must be 75. Okay, and that leaves us then the 40 degrees. That leaves us the 40 degrees to be equal to the 6y minus 14. So we can solve for the y, as it asks us in the directions here. I said solve for y, find the values. So we can add 14 to both sides. So we have 40 plus 14, which is 54. And then divide by 6 on both sides. And divide by 6. And 54 divided by 6 is 9. So find the values of x and y. Well, we just found y. Okay. Now, we need to decide. It says x minus 2y. Well, x minus 2y, that is the side between the 65 and the 75. Right? So that has to be then the 7.5 number. So we're going to have x minus 2y. Well, 2y, since y is 9, would be then x minus 18. And that's going to equal 7.5. Should add 18 to both sides. And it looks like x is going to be 25.5. We have angle O is congruent to angle P. Okay. And the reason is corresponding parts of congruent triangles are congruent, abbreviated CPCTC. And so we have those two equal to each other, definition of congruence. And then substitution. So they're showing you almost like a proof rather than just showing the math like I did. And then 6y plus 54, y equals 9. And then we have NG being congruent to the IT for that reason, and goes through and solves for the x. All right, check your progress. Find the values of x and y. Go ahead and pause your video. All right, we have x is equal to 4.5 and y is equal to 2.75. Okay, so what we know, right? We can write down what we have here. We have angle H is 35 degrees. Okay, that's also going to be congruent to angle F because the corresponding parts of congruent triangles are congruent. So we should have 6x plus 8, right, is equal to 35. And that shouldn't be too hard, right? And then we take 6x, subtract 8 from both sides, and that gives me, what, 27. And then divide by 6. So we have 27 over 6. I guess we can divide that by 3 on top and bottom. And that gives me 9 over 2, which we know is just 4.5. Or 4 1/2 of 4.5. And there it is, x equals our 4.5. All right, so what else do we know? We also know, right, that the j, right, so this is how you should do it, right, the j and then following with the f would be the same as the g following with the h. So we know that the 2.5 is equal to 2y minus 3. So there we go, 2y minus 3 is equal to 2.5. 2y equals 5.5, and then divide by 2, and you get 2.75. And so A is the right answer. Okay, third angles theorem. What is this? So it looks like if two angles of one triangle are congruent to two angles of the second triangle, then the third angle of the triangle are congruent. Okay, well, that should make sense, right? Because the sum, right, the sum of the angles, right, of a triangle are 180 degrees. So, these two, though, right, will add up, to the same sum as these two. since they're both congruent to each other there. So that would mean that this side here would have to be congruent to that angle there has to be congruent to that one, because they both add up to 180 degrees. Oh, this is kind of, so use the third angle theorem. Okay, a drawing of a tower's roof is composed of congruent triangles, all converging at a point at the top. If angle J is congruent to angle K, and measurement of angle J is 72, we're going to find JIH. Okay, well, JIH would be the same, right, as JIK. So, but we know J and K have the same measure because they're congruent. So I think the sum of J and K would be 144. Let's see what happens. So JIK and triangle JIH are congruent triangles. Okay. Triangle angle sum. And therefore the corresponding angles are congruent. So we have then a substitution in 36. Third angles theorem. So that's pretty straightforward. They made it seem harder than it really was. Okay, here's a drawing of a tile. Contains a series of triangles, rectangles, squares, and a circle. Okay, and we know that the triangles KLM and NJL are congruent, and angles therefore KLM and KML are congruent. And also the measurement of KML is 47.5. So measurement of our KML, so this guy right here, right down there, this guy right here, right, is 47.5 degrees. Okay, and your goal, right, is to find L and J. L and J. Go ahead and pause your video. Okay, and measurement of L and J is 85 degrees. Let's see how we can figure that out. So L and J is this angle right here, right, that we need to find. And they're saying that that's 85 degrees. Okay, let's see what we know. Okay, we know that angle, we'll call it angle M, right? Angle M is congruent, right? Is going to be congruent to the angle L, as you can see here. Okay, so we know that the angle L has to be 47.5 degrees. We also know, though, that angle KLM and KML are congruent. That tells us a lot then, right? It tells us right here that KLM, right, and KML, so these have to be the same. So this L right here is also 47.5. Then we can transfer that then to the angle J, because the J and the L are corresponding, right, angles. So this actually has to be 47.5 as well. Okay, and 47.5 and 47.5 does add up to 95, which is good, because then that leaves this angle to be 85 degrees. So we found it. Okay, prove that the two triangles are congruent. It says write a 2-column proof. Okay, now it looks like we have 3 different sides all being congruent to each other, and we have an angle congruent. So it looks like we're going to do something with probably the 3 sides. Okay, using our idea that if we have three sides the same, congruent, that's going to be a congruent triangle. So we're given that angle L is congruent to angle P, and then our three sides, right, LNPO, LNPN, and MNOP, they're all congruent based on those tick marks. And we need to prove, right, that the LMN is congruent to PON. All right, here we go. Now, we're given a bunch of information, so we have that as our reason. It's just given. Okay? Then we could say that LMN is congruent to PNO. Let's look back at that. LMN, right, is congruent to PNO. So we know that these angles here, right, and here have to be congruent. So I'm going to do that by putting a little line through this one and through that one. So far we have, what, three sides and two angles, and we have to get that third angle. But the nice thing is we have the third angle theorem that says if two angles are congruent, right, then the third one has to be congruent. So an angle M has to be congruent to angle O. Let's finish off the proof. There's our third angle theorem. Therefore, triangle LMN is congruent to triangle PON. All right, find the missing information in the following proof. Okay? So, we're just going to walk this one together, okay? So we have QN is congruent to OP and QP is congruent to ON. And that's just given. And those are given by the tick marks. Okay? We also know that angle Q, we'll draw that in, right? Angle Q is congruent to angle O. Let's go ahead and just put a line like that. All right? Now we also have that this side, right, is going to be congruent to itself because of the reflexive property. Okay? So it looks like I have three sides. Okay? It also tells us that NPQ, here it is, this is nice, they give us another angle, don't they? They give us the NPQ, so this angle right here, let me just draw over here, this angle right here, right, is congruent to PNO, to congruent to this one up here. So again, we have by the third angles theorem, right, that we have that this angle down here, angle 3 is also congruent to this angle up here, and therefore we have all three sides and we have all three angles, therefore the triangles are congruent. Okay, so look what it's asking you to do. I want you to fill in the reason. What's the missing reason that angle QNP, I said it out loud if you were paying attention, and if you said the third angle theorem, you are correct. All right, properties of triangle congruence. Okay, we have reflexive property. Basically it says triangle ABC is congruent to itself. Okay, so anytime you have something compared to itself, it's always using the reflexive property. Then we have the symmetry property. If triangle ABC is congruent to EFG, then we can simply flip it around and simply say the triangle EFG is congruent to triangle ABC. And then we have this transitive property. So if two things are equal, we can transfer that to a third. So if triangle ABC is congruent to EFG and EFG is congruent to JKL, then we can conclude that triangle ABC, okay, which is the first one, right, is congruent to the last one because we have two things being congruent to the same thing. Okay, so triangle ABC congruent to EFG and EFG being congruent to JKL, so it makes then ABC congruent to JKL.